In this video, I'm going to talk about ratios. What is a ratio? Let's take a look at an example. Imagine we have three boxes, where one box is white, one box is black, and two boxes are white. We have three boxes in total. Now, we can represent this relationship between black and white tiles in a ratio of 1 to 2, where 1 is black. For every one black tile, there's two white tiles. That's what that means. And we know there's three tiles in total, and therefore 1 plus 2 equals 3. Now, what is the purpose of a ratio? How does it help us? Well, the key purpose is to show the relationship between two or more things. So in this case, the relationship between black and white tiles. Looking at the ratio, the important thing is that the number of white tiles is 2 times the number of black tiles. And the other way around, the number of black tiles is half of the number of white tiles. So that's the first thing to bear in mind. Now, the reason why I say, the most important thing is how much bigger is one number to another. We can write the ratio in several different ways. For example, 2 to 4 will be the same ratio because 4 is still 2 times 2, and also 2 is half of 2 is half of 4. So the relationship is the same. Therefore, we can multiply one, as long as we multiply both sides of the ratio by the same number, or divide by the same number, we get the same ratio. So that's the first point to bear in mind. The second point of ratios is that it shows you the relationship of one part to its whole. Now, what do I mean by that? We already know that there's 1 plus 2 equals 3 parts in total. Now, the relationship of the number of black boxes to the whole is 1 out of 3. The relationship of the number of white boxes to the whole, so that's black, white boxes to the whole, is equal to 2 out of 3. Now, this is another useful way of looking at things. So it just means that if we know what the whole is made up of, we can work out the parts by just taking a fraction of the whole. And we'll look at some examples where you'll see both of these concepts in practice. We have a box of chocolates with 8 pieces inside it. So there's 8 in total, and we're going to distribute the chocolates to John and Mary in a ratio of 1 to 3. How much will John get and how many chocolates will Mary get? Let's use this ratio to figure this out. Firstly, we know that this ratio has 4 parts to it. 4 parts to it. The first thing we can do is work out how much one part is worth relative to the whole. So to work that out, we know that there's 4 parts in total, and 1 out of 4 is going to be John. So John is going to get 1 out of 4 pieces according to the ratio. If we multiply this by the total number of chocolates, we're going to get a quarter of 8, which is 2. So 2 chocolates is what John gets. Now let's see how many Mary will get. So we know Mary has 3 out of a total of 4 chocolates. So if we just multiply that by 8, we'll get 6 chocolates. So Mary's going to get 6. If we add the chocolates together, we get 8 chocolates. So we know that we are doing things correctly. So that's one example of using ratios to work out how much each person's going to get. Now let's look at a few important ideas. Looking at the ratio, we saw that Mary has 3 times the amount of chocolates that John has, and John has 1/3 of the amount of chocolates that Mary has. So that's another important property to bear in mind. Imagine now that we know that John and Mary are given chocolates again. This time John has already been given 10 chocolates. John and Mary have received chocolates in the ratio of 2 to 5. How many chocolates will Mary get if that's the case? We can solve this by firstly working out how much one part is worth. We know that John has 10 chocolates, so 2 parts equals 10 chocs, which means 1 part is equal to 5 chocs. If 1 part is 5 chocs, and we know that Mary is going to get 5 parts, to work out the number of chocolates Mary will get, we just have to do 5 times 5, which is 25. Therefore, Mary gets 25 chocolates. We've seen ratios involving just 2 sections, like 3 to 4. But we can also have ratios with more than 2 sections, like 1, 4, 5, or 2, 3, 4, 6. Whilst this looks a little bit scarier, we use the same techniques to resolve these questions. What does it mean when we have more than 1 section? Well, it just means we're comparing more things. So for example, here we are comparing 2 items. Here we are comparing 3 different items, and over here we'll be comparing 4 different items. That's why there's 4 sections. Let's look at a small example of a question involving 3 sections. Imagine we have a box of 12 chocolates, and I'm going to distribute it to 3 people in the ratio of 1 to 3. Right? Let's work out the total of this ratio first, and then we can work out how much 1 part is worth. So 1 plus 2 plus 3 tells us that there's 6 parts in total given that 6 parts is equal to 12 chocolates, that means 1 part is worth 12 chocolates divided by 6, which is equal to 2 chocs. So that means the first person is going to get 1 part, which is 2 chocs. Second person is going to get 2 parts, which is going to be 2 times 2, which is 4 chocs. And the third person is going to get 3 parts, and we know that 1 part is 2 chocolates, so therefore 3 parts will be 3 times 2, which is 6 chocs. Therefore our answer would be 1 person gets 2 chocs, the other person gets 4 chocs, and the final person gets 6 chocs. So that's how you can solve a question involving 3 sections in ratio.